So prior to today, we have been using right triangles to solve everything. Here's a triangle that is not a right triangle. We have got to have ways to solve not right triangles also, because how many right triangles really are there in the real world? Yeah, exactly. So I'm going to use right triangles to show you how we got the law of sines, but then you don't ever have to do this again. You just observe and do it with me. But really, we're just going to use the law of sines. What am I drawing here? The height, the altitude, or the height, yeah. When we were in geometry, I don't know what your geometry teacher told you, but usually when I teach geometry, if I have an angle that's marked capital A, the side that is opposite, I'm going to call little a. Okay. And if I have an angle that's marked capital B, the side that is opposite of it will be affected by the angle, so I call it little b. And then that means that this long side here is going to be called little c. So when I use these letters, you see where they're coming from. And if you look ahead to the law of sines, you see it has a little a, b, and c in it too. Okay. I've made two smaller right triangles within this. And how would I get this height? Like according to angle A. Now I only have variables. I don't really have any measurements here. But if I knew angle A, H would be the what? The opposite, and I would use B to be the hypotenuse. So this would be sine of angle A is equal to H over B. I would also be able to get side H by using angle B and using sine as well. If I did sine of angle B, that would equal H over A. So I have two equations here that are true, and both of them have an H in it. So I'm going to solve both of these for H. So how would I solve this one for H? Cross multiply, or multiply by B. Yeah, so I would get H equals B sine angle A. Right? And then for this one, I could cross multiply or multiply by A, and I would get H equals A sine B. Now if H equals both of these, then guess what about both of these? They equal each other. That's right. So B sine A equals A sine B. Now what I'm going to do is I'm going to divide both sides. I'm going to divide both sides by A and B at the same time. So if I divide both sides by A, nothing happens over here, but on this side, the A's cancel out. If I divide both sides by B, nothing happens on the right side, but on the left side, the B's cancel out. So I'm left with sine of angle A divided by A is equal to sine of angle B divided by B. So I never even need to know the height. I just need to know lengths and angles. Now, there's no reason that A and B had to be the two that I picked it. Like I could turn this triangle a different way and draw it again and do the same thing again. It would end up allowing me to also find that sine of angle C over C is equal to these as well. So that's how we got the law of sines formula. It came from right triangles. All right. So this is law of sines formula. If we need to find an angle and we know its opposite side, and we know another angle and the other side, you have to know three things to be able to solve for a missing piece. Or if we need to know the angle and you know two sides and you also know this side's corresponding angle or opposite angle, we can solve. Now this shouldn't take too long. So this works. You guys remember this from geometry, AAS or ASA? Do you remember that from geometry? Not that you could pull it out and do a proof right now, but you remember talking about that. That's how we prove triangles congruent. So if you have AAS, you can use law of sines. If you have ASA, you can use law of sines. So for this particular one, it's giving you a bunch of information. We are going to use AAS to find the remaining angles and sides. So we're going to set this up. Angle B and side B are both given. So this is what I'm going to use to help me solve. So we're going to do sine of 28.7 degrees divided by 27.4. Now you can't really solve all the missing pieces at the same time. So I'm going to look here and I say, well, I know the angle C is 102.3 degrees. So I'll say sine of angle C, I don't know that number, sine of angle C, which is 102.3 degrees, divided by little c, which I don't know. They have to be equivalent. How can we solve? Cross multiply. So when I cross multiply, I'm going to get C times sine 28.7 degrees equals 27.4 times sine 102.3 degrees. And then divide both sides by sine 28.7. And we should have what little c equals. Let's put up here. And thank you for doing this at the same time as me with your calculator so that you know how to use your calculator when it's on your own. I got 55.747 feet. That seems kind of big, but then when I go look at my picture and this smallest side is 27.4, then now I'm like, okay, maybe that could be my answer. Now if I got an answer that was like 2.3 feet, maybe I'd think I just did something wrong because that does not make sense for my situation. So definitely think about it. So we found one missing side. We have to find the other missing side and the other missing angle. How could I find that missing angle? 180 degrees. Subtract off 102.3. I don't know if this is what you're saying, Neil. I couldn't hear you. Minus 28.7. And I will get measurement of angle A. Remember when you write measurement angle A, sorry, little geometry review for you. When you write measurement of angle A, it's like a little M, angle A. Wow, 49 degrees exactly. So now, when I go do the second part to find side A, I am not going to use side C. Just in case I found C wrong, you know, maybe I typed something wrong in my calculator. It happens, I do it all the time. Maybe I found C wrong. I don't want to like find side A off of a wrong answer, so I'm going to go back and use B again, because that one I know for sure, that's what's given to me. And then we'll cross multiply. We'll do it the exact same way we just did that one. And then divide by sine 28.7. And we should have little a. You see, that's like almost the exact same work that we did the first time. So it should be pretty easy. Did you guys get 43.061? Did anybody get that, or is it just me? You got it? Okay. So that's law of sines to solve missing parts. So this one here, the bell's going to ring in like 2 minutes, but you guys can start working on this one. This is just not finding everything. It's just finding the angle of elevation from the tip of the shadow to the top of the pole. Oh, no, they gave me that. Sorry. How tall is the pole? So the pole is leaning. So it's not a right angle anymore. It used to be a right angle. So we can use law of sines to find how long A is. Nope, I can't use that. So the first thing I did was find angle C is 39. We'll finish after lunch. Have a good lunch. Okay, so right as the lunch bell was ringing, we were saying that this angle up here, angle C, across from side little c, we can set that up for law of sines. And then we have to solve for little a, and we know angle A is 40. I'm sorry. I saw it moving. This is on my screen. So we're going to solve for A. Here's little a, and that's across from 43 degrees. So I have my C's set up. Now I'm going to do sine of 43 degrees over little a. So it's the same thing that we just did. We're going to cross multiply. And we're going to divide by sine 39. And so I get about 23.842 feet. And I would say that's reasonable because the 22 feet along the bottom, there's a 43 degree angle there. Up here there's a 39 degree angle. So these angles are fairly close to each other, so these sides are going to be fairly close to the same distance. You guys remember that from geometry where like the smallest angle is always across from the smallest side, or the size of the angle determines how big the side is. So since these are fairly close in numbers, I would figure that 22 and 23.842, those would also be close in numbers. So it makes sense. All right? So that's law of sines. Now this is the hardest part about law of sines. I mean, it's not hard. It's just like the most work. There is one more case for law of sines. It's called the ambiguous case. And the reason why nobody likes this one is because there's all these different possibilities. When you would use the ambiguous case is if you have information in the form of ASS. Okay? Do you remember from geometry? You were not allowed to prove triangles congruent by ASS. Do you remember? You have to remember. That's the one thing you've got to remember. Do you know what I'm really saying? Okay. Okay. Nobody smiled, so I wasn't sure. My sophomores giggle, but you guys are all mature, so I get it. So if you have SSA or ASS, if you have two sides and an angle that's not in between those two sides, you actually have to like check some information to figure out what you're actually able to solve for. So there's different cases. And these are all the different cases, and it might seem a little confusing. If you know angle A and you know the side opposite angle A, so that's every single case here has angle A and side A. Now, it might not be called A. It might be called X. But if you know an angle and the side opposite it, that's the first start for SSA. And then the other side is going to touch that first side. And they call it B. But it might not be B, it might be Z. Okay? Could have different letters. We're just using those as placeholders. You do need to know the height for some of these, well, for all of these cases. No, not for all of these cases, for some of these cases. So if we have SSA, you have to look at these necessary conditions. If the value of A is less than the height, you will not have a triangle. So you couldn't even solve anything. Okay, so you need this information. Will I give you this? Sure. Okay, you don't have to have this memorized. If your height and your side A are the exact same thing, you will only have one triangle possibility. And you go ahead and solve it, but there's only one triangle possibility. Just like all the others only had one triangle possibility. If your A value is, you will only have one triangle. So this, you just like do this normal, nothing special. This one, you just say, I'm sorry, I can't do that. There's no triangle here. Now here's a special case. If the A value, if the side that is across from the angle given, if it is bigger than the height, but smaller than the B value, there's two possible triangles. And so you have to find both answers. So here's one of those triangles. And then the other triangle would be this here. Both of those have that value of A. They still have the same height. It's just, and they still have the same angle A. It's just this side at the bottom is different for both of them, and this angle over here is different for both of them. Can you tell me something about this angle and this pink angle that you can notice that's different about these two angles besides they're different? That's right. Who said that? Yes. One's acute and one's obtuse. So when you have this situation, you will have to find an acute angle and an obtuse angle. And then if A is less than or equal to B, you will have no triangle. You couldn't do it. Move on. And the last one, if A is greater than B, you will have one triangle. So that's the first thing, is you're going to have to figure out what kind of triangle you have. So we have our first example, we have SSA. See how we have the angle 4 degrees and we have the side opposite, and then we have this other side that is not that does not have the angle in between the two. It's over here. So this is SSA. And we look at the values, and our A value, 22, is bigger than our B value. So we go up here. Where is A bigger than B? Here. This is where A is bigger than B. So we'll have one triangle. We just have to solve it a normal way. So we would do like sine of 42 degrees over 22 inches equals sine of angle B over 12 inches. So I didn't show you how to solve for an angle yet. I'm going to do that now. And then I probably won't finish all of the stuff for this because I want to make sure that I just give you guys notes and not take up all our time. What time do we get out? Do you know? Should I look? What? 50? It's 50. Okay. Just, I want to make sure that I get through all the examples for you so you have notes. Okay, so if I'm going to solve for the angle, we're going to still cross multiply. And we'll get 22 sine B equals 12 sine 42 degrees. And we need to get B by itself, but I can't do that yet. I can only get rid of 22 to start. So I have sine B equals 12 sine 42 degrees over 22. I may have left this space on purpose. So when you need to solve for the angle, you have to cancel out sine, and what's the only thing that will get rid of sine? It's the inverse of sine. So we're going to use sine inverse to both sides. So that cancels the sine. We get angle B over here. And I know it's going to be approximate. And then you're just going to type that into your calculator. So make sure you try it on your calculator because we all have different calculators. Make sure you know how to get it on your calculator. So I got 21.406, unless I typed something in wrong. Did anybody else get that? Okay. And again, there's more to this one, but I'm just going to move on. When you do go to use, when you do go to find the rest of this one, I use this every time because that one I know for sure. Like, I'm not going to use this number if I don't have to. Actually, I will have to just find the other angle, but. Okay. So here's the next one, and you'll like this one because you can see if you read the directions what it's going to come out as. But so we have show that there is no triangle for which, okay, so I'm going to draw a triangle. Little a is 15, capital A is 85 degrees, and then little b is 25. So I didn't really do this to scale. I could do it to scale to make even more sense. Like 25 and 15, right now my 15 looks like it's way longer than my 25. So if I did it more to scale, it might look more like this. But 85 still has to be 85 degrees, so. Okay, why is there no triangle? So we've got SSA. We know our A and B values. What do we know about our A and B values? What's bigger? B is bigger. So we go up here. That says A is bigger. And then here's where B is bigger, where A is less than or equal to B. So right there, that would be why it was no solution or no triangle. So A is less than B. Okay. Oops, I waited. So you're going to have to use this chart again. I will give you the chart. You don't have to memorize it. Okay, so this is the last part of the ambiguous case. This one's going to have 2 solutions. We're going to stay organized, right? We're not going to write huge. Do you understand? Okay. Find 2 triangles for which A equals 12, B equals 31, and A equals 20.5. So I'll show you my 2 triangles. One triangle is going to be like, so A is 20.5. B is 31. Hold on a second. Did we mess up on this one? Huh. We need to go back to this for 1 second. I apologize to anybody watching my video and anybody in the room. I saw this as I was turning the page and then I wasn't thinking. I do need to go back to this. The example I just used to prove this, I can't use that one. Do you know why I can't use this example to prove it? I forgot something that's written above it. This is only when A is obtuse. Whoops. Here's where A is acute. So we actually had to look at these 3 situations. Oh, 4 situations. 4 situations. So, oops. We got to prove it a different way. Sorry, guys. Then we'll go do the other 2. That was a nice try. That wasn't it. Acute. I can tell by the picture it doesn't work, but if it's acute, there is one that says A is greater than B, but that's not my case. I have A is less than B here, and I have A is less than, I don't have any other A is less than B. However, these 2 have to do with H. So because it's not this, actually all 3 of them have to do with H, don't they? So if it's not this one, I have to find H. But H is really easy to find. Here's the formula for H. B sine A, which came from when we were first doing this stuff. You know, my formula for H is B sine A. Look, there it is right there. So that's where my formula for H comes from. But we are going to have to find H for this one. So I'm going to do B sine A, which would be 25 sine 85. And I get 24.9-ish. So A is 15, B is 25, and H is 24.9, almost 25. So when I look at my cases, A is definitely less than H. Here, this says A is greater than H. Here it says A is equal to H. No, A is less than H. So it's actually this reason why. That's my reason that these cannot be a triangle. Sorry about that quick little mistake. I'm trying to hurry. That's the problem. Okay, now we gotta hurry. I'm gonna get through this one. The very bottom one is so easy. That'll take me like 30 seconds to explain the last question on here, but this one's going to take me maybe 6 minutes. Okay. All right, so we've got 2 triangles. The first triangle, why do we have 2 triangles? This is acute, and A is 12. And B is 31. So A is less than B. So if A is less than B, I've got 2 choices. This one here I need the H for, so let's go ahead and find our H. H is So I'm going to do 31 sine 20.5. And I get h is 10.86. So then when I go and I look, is h the smallest? Does it go h, then a, then b? Does it go in that order? So that means we have 2. So this is like h, a, b. We're going to have 2 triangles. Okay, so now we have to find like all the information for both triangles. So one of them is going to look like this, and then the other one is going to look like this. No. So when you have 2 triangles, this angle B, one of them will be acute and one of them will be obtuse. Okay, so we can use law of sines. What do we know? We know the A. So sine 20.5 over 12 is going to equal sine of B over 31. So we just did that on the other page. We're going to cross multiply. I'm going to get sine B is 31 sine 20.5 and then divide by 12. Is it okay that I just did that in one step? I did cross multiply. I'm just trying to hurry. Did it one step. Okay, but then what do we have to do to type it in the calculator? We have to do sine inverse. So these will cancel. We'll do sine inverse. So that's what I'm going to type in my calculator. Hmm. 64.783 degrees is what I got for angle B. So we can find the measurement of angle C by taking 180, subtract off angle B, subtract off 20.5, which was angle A. So on my calculator, I'm going to do 180 minus my answer, and then minus 20.5. So measurement of angle C is approximately 94.717. So I've got measurement angle B, I've got measurement of angle C. Now I need to find side C. So for side C, I'm going to again use the A. Sine 20.5 over 12. I'm going to use angle C, which I just found. Sine angle C. I'm going to use the calculator version of it. I'm not going to use a rounded version. So sine C over, we don't know, C. But we do know angle C. It's on my calculator. So I'll cross multiply that, and I'm going to get C equals, so I'll have 12 sine whatever my angle C is on my calculator divided by sine 20.5. So 12 sine answer divided by sine 20.5. That was kind of fast, but could you follow? Was there anything that I did that you didn't follow, that you have to ask me about before I go on? Yes, Neil.
So, is there not 2 different measures for angle B?
There is, but I've only found one so far. That's where the second. I like to like make 2 columns because we're actually going to do all the same steps in the same order. You're just going to have a different angle B. Are you ready to find the other one? Okay. So, so angle B, when we found this one here, what you're going to do from this angle is you're going to, like if this was these are both going to be 12 here. If I swing this around, these will 12. This one right here is 12. You know, if I put the original one there. This is an isosceles triangle. So this angle B is going to be the same as the exterior of this angle B. So how do I find the interior? Yeah, those are a linear pair. So we take, for angle B, we're going to take 180, and we're going to subtract off this answer from before. So remember how I told you to store stuff? For those of you that have that older calculator and can't go up and like pick the answer from before, this might be a good one where you use the storing function. Or you can just retype in what you had before by doing second enter, second enter, second enter, second. Oh, I cleared it. Well, I can't do it. I'm going to have to retype it in now. So I just clear. Oops. Sorry, I got to catch up to you now. 31 sine 20.5 divided by 12. So I'm going to take, no. What did you do wrong? Oh, inverse. Whoops. Forgot that. Sine inverse, because it was written in a different color off to the side. Sine inverse of my answer. There we go. So there's my 64 point whatever it was. So I'm going to take 180. I'm going to subtract off that answer, and I get 115 point. $115.217 degrees. Okay, so once I have the measurement of angle B, I'm going to follow all these same steps. So angle C now, I'm just going to take 180, subtract off this angle B, subtract off 20.5. it's just two problems for the price of one. That's why nobody likes this one. Don't you feel bad for it? Or do you not? You don't feel bad at all? Okay. So measure of angle C would be approximately 44.283. And then we will do our cross multiply. The same thing that we did right here. We're going to do again. So we're going to use sine 20.5 over 12. And we're going to do the sine of my new angle C, which is up there, divided by C. Cross multiply. I get the exact same thing I got over here. C equals 12 sine whatever this angle C is, which is new on my calculator, divided by sine 20.5. So I could even reuse what I used before because it was using the answer from above. So 23.924. It's not terrible. Just doing the problem twice, basically. Okay? The very last thing, I told you it's going to take me 30 seconds to do this last one. This is an area of a triangle formula if it's in the form of SAS. If it's in the form of SAS, you can find the area of the triangle by this easy formula. You take half of two sides, and then the sine of the the sine of the angle that's included between the two sides. So it doesn't have to be A, B's, and C's. You just take half of the two sides multiplied together, so half of 52 times 90, and then you multiply that by the sine of that included angle, which is 102 degrees. And that's the area formula for this kind of triangle. Meters squared. Remember area, you write as squared. Just a little reminder about that. See, that one's pretty easy. So I have given a short 3-question assignment because that was supposed to happen last class, but then I just let you guys review the whole class. And then on top of that, the second worksheet has to do with this stuff. Okay? But the first work, what? Yeah. You have till Monday to do them. You have an XH tomorrow. Yeah, so that's the first and the other assignment. Yeah. I felt like we could combine them because the first one was only 3 questions. Okay. And you do have 2 school days. This is technically 2 school days. So I don't like to push and squeeze it all in, but like that's unfortunately I let you review more in class last time. So we had to make up for that time somewhere, and that was today. But you can come see me. I felt like review was more important to you at the time.